Okay, guys, so we are doing lesson 4.3, and this is finding complex solutions by completing the square. So when we learned how to shortcut finding equations for quadratics by using the calculator and skipping completing a square, told you it was going to come back to bite you in the tushy, and it is. So we are going to have to do that all over again. And so that's what this section is kind of about. So the first thing we're going to do is look at solving to complete for a square. So our example number 1 is talking about how to do that. So if we just look at part A is all the steps that we do. So they've numbered it. There are 4. But within that 4, there's multiple steps. So let's take a look. So how can we find the solutions to this? Okay, so first what they did is they took the equation. They added the 6 to both sides to get x squared plus bx by itself and something else on the other side. So that's how we got here. Then what they did is they noticed that all of these numbers can be reduced by the number 3. So they divided everything by 3. And that gave them the final answer, x squared plus 3x equals 2. Okay? Then we identify b, and what would be our magic number? B over 2 squared. So our b is 3. It's that middle number. So we plugged in the 3. So 3 divided by 2 squared is 9/4. So we add that magic number to both sides of the equation. Okay? Then what happens is, what we've done is we made a perfect square. So what they did is they're going to come back and turn this into this. Because x squared is a perfect square. Its square root is x. 9/4 is a perfect square. The square root of 9 is 3. The square root of 4 is 2. So that middle number inside of here reappears over here inside that parentheses with a squared on the outside. And then they have the 9 plus 9/4. Or the 2 plus 9/4. Then they reduced, or they combined. 2 plus 9/4 is 17 over 4. Then they square rooted both sides. Okay, so we got rid of this squared, and we ended up with x plus 3/2 equals square root of plus or minus 17 over 4. So square root of 17 doesn't reduce, but the square root of 4 turns into a 2. So that's how we got here. Then they subtracted 3/2 from both sides. So negative 3/2 plus or minus the square root of 17 over 2. They have the same denominator, so here is our answer. Negative 3 plus or minus the square root of 17 over 2. So there are 2 real solutions. Negative 3 plus the square root of 17 over 2, and negative 3 minus the square root of 17 over 2. Because this could have, the square root of 17, 2 things multiplied together, would have gotten us, we could have either multiplied 2 positive numbers or 2 negatives to get us inside of there. So 4 steps. Within the 4 steps, we had a lot. And that is okay. We can do it. We've already done this simplifying part before. Okay? And then we're just adding. It is not going to be too terribly difficult. So let's work our way through part B. So if we look at part B, I'm going to try to zoom in. There we go. So x squared minus 2x plus 7 equals 0. So first we write the equation, and x squared plus bx plus c. So what we're going to do, we're going to subtract the 7 from both sides. So we end up with x squared minus 2x equals negative 7. Identify b, and what would be b over 2 squared? So b is negative 2. So that would be a negative 2 over 2 squared, which, by the way, guys, that reduces to a negative 1. And a negative 1 squared is a positive 1. So I'm going to add that to both sides. So when we move over here, we have a plus 1 and a plus 1. Now remember, they miswrote. That should be a minus 2x there. Okay. So remember, we got a negative 1 was inside of this. So we end up with a minus 1 over here because x times x is x squared. X times negative 1 is negative 1x. Negative 1 times x is negative 1, so that's how we get the negative 2. And negative 1 times negative 1 is positive 1. So that works. Negative 7 plus 1 is a negative 6. We square root both sides. So we end up with a negative 6 here. And we are okay. Oops, that moved. And an x minus 1 over here. We add 1 to both sides. So that's how we have a 1 in front. Times the square root of negative 6. Well, the square root of negative 6, we can't take a square root of a number, so we know that that negative comes out as an I. So we know that we have 1 plus or minus I times the square root of 6. So do we have real or non-real solutions? We have non-real solutions. 1 plus I square root of 6. And 1 minus I square root of 6. Okay? Not too bad, guys. It'll be okay. The tears can end soon. Let's do it 2 more times. Nobody needs to cry. We will all survive. Just dropped my book. Okay. Move the 17. Move the number over. Minus 17, minus 17. X squared plus 8x equals negative 17. B equals 8. So b over 2 squared should be 8 divided by 2 squared, which is 4 squared, which is 16. So we end up with x squared plus 8x plus 16 equals negative 17 plus 16, which reduces down to x plus whatever was inside the parentheses before, 4 squared, equals negative 1. This is going to be easy, guys. Square root both sides. So we get rid of that squared, and we end up with x plus 4 equals the square root of negative 1. Minus 4 from both sides. We end up with x equals the square root of negative 1 minus 4. Well, we know the square root of negative 1 is just an I, so x equals plus or minus I minus 4, which I would rewrite that as negative 4 plus or minus I. So we have 2 non-real solutions. Where x is negative 4 plus or minus I. 2 non-real solutions. So let's take a look at number 6. We're going to add 7 to both sides. We end up with x squared plus 10x equals 7. Our b is 10. So our b over 2 squared is 10 over 2 squared, which is 5 squared, which is 25. So we end up with x squared plus 10x plus 25 equals 7 plus 25. X plus 5, that was the middle number, squared, equals 32. Square root both sides. X plus 5 equals the square root of, can I take any perfect squares out of 32? I can. That's basically 16 times 2. 16 is a perfect square of 4 and 4. So that means I can pull 16 times 2, which is the same thing as 4 times the square root of 2. Okay, minus the 5 from both sides. X equals negative 5 plus or minus 4 square root of 2. We end up with 2 real solutions. Here is our answer. X equals negative 5 plus or minus 4 times the square root of 2. There are 2 real solutions. we ended up with an I because we ended up with a negative under the square root. So that's why we had two non-real solutions. This one, we had a positive number under the square root. So we have two real solutions. Okay, next we're going to talk about how to kind of fast track and identify real and non-real solutions.